Okay, in this video I'm going to demonstrate the tests for halide ions. Some of you will have, at least in part, met this in Separate Award GCSE. I'm not going to offer any particular explanation. This video is mostly to show you what happens. Explanation will follow later. So I have three solutions. This is potassium chloride, so it contains chloride ions. So I'm going to put some potassium chloride into my first test tube. Isn't there? Second solution is potassium bromide, so this contains bromide ions. Put that into my second test tube. You can see which is which. We have bromide ions in the second test tube. And then, last but not least, I've got potassium iodide solution with I- ions, iodide ions, and I will put that into my third and final test tube. Okay, so we have test tubes with aqueous solutions of three different halides. Now, the first part of the test is to add nitric acid to each of these. Now, the job of this is to react away any unwanted ions, such as carbonates, which could affect the test result. So we add nitric acid first. It's not specifically part of the tests, but it's important that we add this to remove anything that would give us a false positive. The essence of the test, though, is that we add silver nitrate. And essentially what's happening here is that we're adding silver ions, Ag plus ions, and these will precipitate with the halides. So Ag plus Cl minus ions give insoluble silver chloride AgCl solid, so we will see a precipitate. So if I add the chloride ions now, the silver nitrate to the chloride solution, you will see I get a white precipitate of silver chloride forms. If I do the same with the bromide ions, in this case I get a cream coloured precipitate of silver bromide. And last but not least, if I add silver ions to a solution with iodide ions, I get a yellow precipitate of silver iodide. So those of you who did Separate Award GCSE will have met those tests before. You will also remember really from GCSE that with the naked eye it's really very difficult to distinguish between white, cream and yellow. So we're now going to introduce a further part to this test, which is to see what happens when we add ammonia solution. So what I'm going to do is I'm going to add dilute ammonium hydroxide or an ammonia solution to the first tube with chloride ions and see what happens. to just get rid of some of that. And what I hope you can see is as I add dilute ammonia to the solution with silver chloride, the precipitate disappears and I'm left with a colourless solution. If I repeat the same process with the bromide ions, the silver bromide, and add aqueous ammonium hydroxide, you'll notice that this time the precipitate remains. It does not dissolve in aqueous ammonia solution. However, just get rid of a little bit of that. If I now add a concentrated solution of ammonia, so concentrated ammonia solution, hopefully this time we will find that the precipitate does disappear. Takes a little bit of doing, but I hope you can see that that has now become a colourless solution. So with bromide ions, aqueous ammonia is not sufficient to remove the precipitate, but a concentrated solution of ammonia will remove the precipitate. The final one is the iodide, the silver iodide. Now I can tell you straight without demoing it that aqueous ammonia solution, dilute ammonia solution will not remove this. I'm now going to try adding the concentrated ammonia solution. And I hope you can see that even with the concentrated ammonia solution, the silver iodide precipitate remains. Now this now gives us a more definitive test for the three ions that are better than the white precipitate, green precipitate, yellow precipitate. A silver chloride precipitate can be removed with aqueous ammonia solution. A silver bromide solution cannot be removed with aqueous ammonia solution, but it will dissolve with concentrated ammonia solution. However, a silver iodide precipitate will not disappear either with dilute or concentrated ammonia. That's the end of this video. More later.